Discord. Hello. What's the first step of logarithmic differentiation? You got it, Dean. Perfect. So I take ln of both sides. So here I would have ln of y is equal to ln of all of this stuff. And why is logarithmic differentiation a good plan in this question? Why would I think to use logarithmic differentiation here? So because of the chain rules partially, but also because of, so it's a mixture, you got it, there we go. It's a mixture of chain rules and product rules. And so actually I'm gonna go up here and also give us another reminder. We said that this is useful when we have a big mixture of chain rules, product rules, and quotient rules. So if I just had 3 times x squared plus 7 to the 5th times x squared minus 2 to the 4th, it might make sense to just do the derivative. It's one simple product rule. It's a derivative that you guys would be comfortable with, that you've seen a lot. But how many things am I multiplying together here? Oh, thank you, Nick. How many things am I multiplying together here? I mean, really, I'm multiplying 4 things together. And if you don't count the constant, it's still 3. And what's the max of number of things we've ever really done multiplied together with the product rule before? 2. So this is the product of like 4 things if we count the constant, and not just 2. So that's right there is like our key, that, or our clue that logarithmic differentiation is a good plan. Okay, so what is the first log rule that we're going to use here in our step 2? So now we want to simplify. Which rule am I going to be using here? You got it, rule 1. I'm dealing with my products first. So my rule 1, and remember we said it's a product of 4 things. Remember we said that we always want to make sure that we include the constant, as one of the things in the product. So what that means is I'll have ln 3 plus ln of x squared plus 7 to the 5th plus ln of x squared minus 2 to the 4th plus ln of e to the 3x squared minus 9. Are there any more rules I can use here? Is there any more simplification that I can do? Good job, guys. I can use rule 3. So now we're going to say ln y is equal to, and I'm using rule 3 here. I'm also going to be using one of the stars. So I'll have ln 3 plus, I can bring the 5 to the front, ln of x squared plus 7, plus I can bring the 4 to the front, ln of x squared minus 2, plus, what is ln of e to the 3x squared minus 9 equal? It just equals to the function. It just equals to 3x squared minus 9. Now there's no simplification left to do. This is my simplified form. So now we take the derivative. What is the derivative of ln y? You got it. We have y prime over y here. What's the derivative of ln 3? You got it. Remember, ln 3 is a constant. Its derivative is 0. So I'll have 0 plus 5. Now I'm doing x squared plus 7 prime over x squared plus 7 plus 4, x squared minus 2 prime over x squared minus 2 plus 6x minus 0. Clearly, I don't have to write the zeros. I just did so that it's clear that we took the derivative. Okay, so our last step here, our step 4, is to multiply that y over. And when I multiply the y over, what is it? Should I write y or something else? You got it, Dean. The original function. So I don't write y when I multiply the y over, I write the original function. So I'm going to have 3 times x squared plus 7 to the 5th times x squared minus 2 to the 4th times e to the 3x squared minus 9. All of this times 10x over x squared plus 7 plus 8x over x squared minus 2 plus 6x, and this is my final answer. This is my y. You guys remember how logarithmic differentiation works? You feel comfortable with this at this point? Are there any questions about this before we add a couple things? Okay, so I'm just going to go back up for a second. I'll go back down for those of you still copying. Here, remember that we said yesterday and reminded ourselves, logarithmic differentiation is useful when we have a big mixture of chain rules, product rules, and quotient rules. It is not useful, very specifically not useful, when we have a whole bunch of pluses and minuses everywhere. This is because I can't distribute a ln into an addition or a subtraction. So these two things are not equal to each other. So in this, oh, could I go up a little? Sorry, Emil. Is that enough? Is that enough, or do you need more? What do y'all think? Would logarithmic differentiation be useful on this function right here? have a no. What does everyone else think? Nah, definitely not. So the answer is no, because of those pluses and minuses. This is being subtracted. These are being added. That's being added. So in this case, all logarithmic differentiation would do, it would get rid of my quotient rule, but then it would create two chain rules inside of chain rules. So like it would actually probably make this problem a little more challenging. So the answer here is no, because of the pluses and minuses. Okay, so can I move down now? You guys have that down? Okay. So sometimes logarithmic differentiation is necessary. Exactly, Nick. In this case, you would just use the normal rules to find the derivatives and not the log one. So in this case, you would do a quotient rule, and unfortunately, inside of that quotient rule, you would have part of the numerator being a product rule, and in the denominator, you would have two chain rules. And you just have to suck it up and do it. Hopefully you won't have to, but yes. Good. Okay, so in some cases, there's a certain type of function that could happen where logarithmic differentiation is necessary. And we're going to look at when that happens, but first we're going to look at things that we already know. So just a reminder of some things that we already know. What is the derivative of x to the power of n? You got it. It's nx to the n minus 1. And if x is a function, then we have g to the power of n, which is in g to the n minus 1 times g prime. Okay, so in this case, in both of these, my x's are in the base. And so we use this rule, this power rule, when my x's are in the base and the number is the power. So here we can say x's are the base, number is the power. We also have this rule right here, a to the x. What's the derivative of a to the x? There's ln a involved for sure, but not just ln a. You got it. So it's a to the power of x times ln a. Or I could have a function up there as well, and it would be a to the function times ln a times the derivative of that function. And in this case, the number is my base, and I have x's up in the power. So the new question is, what if instead of having, so in both of these cases, I have numbers. In the first case, I have a number as the power. In the second case, I have a number as the base. But what if I don't? What if I have a function to the power of a function? So what if both of the things are functions? In other words, what if I have something of the form f to the power of g? So I have x's in the base and in the power. And the answer is, in this case, we must use logarithmic differentiation. And I'm going to start with the simplest version of this before we make it a little more challenging. So this, I cannot bring the x to the front. I can't do this. I can't be like, well, I can't be like x to the x prime is equal to x times x to the x minus 1. That doesn't make sense because this is not that first thing that we have there. The power is an x, it's not a number. So this is not okay. And I can't say x to the x is equal to x to the x times ln x, because this is not the second thing, because my base is not a number. So we have to use logarithmic differentiation here. That's going to be the method that we have for dealing with this when it happens. I have x's down in the base and x's up in the power. So we're going to follow exactly the same steps for logarithmic differentiation that we have up until now. My first step is take ln of both sides. So I'm like, ln of y is equal to ln of x to the x. And now I want to simplify. What simplification can I do here? 1 the product, 2 the quotient, 3 the powers. I can do my third rule. You guys got it. Good job. I can do my third rule because I can bring that x down to the front. So I'll have that ln y is equal to, here I'm doing the third rule, x times ln x. I don't know why I put that x up as a power, times ln x. Is there any more simplification that I can do? Got it, Nick. So at this point, I can't simplify anymore. I have a product. This is going to be a product rule. So at this point, this is my simplified form. And notice what's cool about my simplified form, or really what allows me to do math about my simplified form, is that that x is no longer the power. I was able to turn that x into a multiplication. So now this is a product rule. So we take the derivative of both sides. What's the derivative of ln y? Y prime over y, you got it. Y prime over y is equal to the product rule. So the derivative of the first times the second plus the first times the derivative of the second. And then my fourth step is y prime is equal to, I multiply y over, but what do I write instead of y here? The function, so x to the x, times ln x plus, well, it turns out that that's 1. And this is my final answer. Okay. Are there any questions about how we just applied logarithmic differentiation to this thing, or why we applied logarithmic differentiation to this thing? Okay. So then there's a thing I want to point out. For some reason, when people are doing logarithmic differentiation, most of the time they forget about the product rule. But when you are doing logarithmic differentiation because it is necessary, because you have to, 100% of the time you will have a product rule. So you should be on the lookout for that product rule. So let's put a big star here and write that down. When you are doing logarithmic differentiation, okay, any questions about this? All right, so this question, y is equal to 2 sine x to the power of cosine x plus 1. Is logarithmic differentiation necessary here? Yes. I have x's down in my base, and I have x's up in my power, which tells me that logarithmic differentiation is necessary. Good job, guys. So let's do it. Now, there's a little trick that's going to happen in this one, or a little thing that we have to think about, rather. I'm taking ln of both sides, so I have ln of y is equal to ln of 2 sine x to the cosine x plus 1. Now I want you guys to pay really close attention. The product, rule 1 product, rule 2 quotient, rule 3 powers, which one am I using first here? Pay really close attention. Think about one of the things I've been telling you about constants. What do you guys think? So Mikhail has an answer. Spain has an answer. Yes. So we have to deal with the product first because, so when we look at this, I have 2 times sine x to the cosine x plus 1. Is 2 to the power of cosine x plus 1? No. So here, 2, oops, is not to the power of cosine x plus 1. So I actually must separate it away before I can bring the power down. And this is why yesterday I told you guys that you really should get comfortable with thinking of constants as their own thing. Because if that constant is there, it stops me from bringing the power down. So what that means is in my step 2, the first thing I'm going to do is ln y is equal to ln 2 plus ln of sine x to the cosine x plus 1. Okay, now, so there I used my rule 1. Now can I go to rule 3 and deal with the power? Yeah, so now I can bring the power down. Everything inside of that thing is to the power. So now I'm doing my rule 3. And I get that this is ln 2 plus cosine x plus 1 ln of sine x. And I want you guys to be careful about those parentheses. These parentheses I put around the cosine x plus 1 are necessary. It is wrong without them. Now, do you guys see the product rule that appeared that we should be on the lookout for? Y'all see it? What is my F for my product rule? You got it. My f is going to be that cosine x plus 1. So that's like my f, and that's my g. Now that g, the ln is included. It's not ln times sine x, it's ln of sine x. So I'm just going to point that out. That is ln of, not times. I don't have the product rule there. So now I can take my derivatives. What's the derivative of ln y? I know I ask you every time, but this way you'll never screw it up. Y prime over y. Good job. Then what's the derivative of ln 2? The thing that you guys all missed on your tests. Good job. 0 plus, now I'm doing my product rule. The derivative of cosine is? Negative sine x. So this is negative sine x plus 0, the derivative of the first, times the second, plus the first, times the derivative of the second. So this is a sine x goes on the bottom. What goes on top? What should I put on top? You got it, cosine x. So then my fourth step, I multiply my y over. And my y was 2 sine x to the cosine x plus 1 times negative sine x ln of sine x plus cosine x plus 1. I can turn that into a cotangent x if I want to, but I can also just leave it cosine x over sine x, and that's equally fine. And this is my final answer. Okay, are there any questions about this problem? So what I'm going to do now is I'm going to write a whole bunch of problems, and we're going to do as many of them as we can before the end of class. But what we're going to do before we even start them is look at them and identify, is logarithmic differentiation necessary, helpful, or neither? So necessary, helpful, or not helpful? Do you guys still need the notes up there, or can I move down like this? Is this okay? Emil, how's that? Is that enough? Okay. I'm gonna give you guys a second to get these down, and I want you to just go through and label them. Necessary, helpful, neither. Actually, I'm gonna go get more water, and when I come back, I want you guys to go through and tell me which one is which. When the X's are in both places, that means it's necessary. So I have X's down here, oops, I have X's down here, and I have X's up here. So in B, however, yes, there are places where I have X's down in the base, and there are places where I have X in the power, but they're not together. So this is just helpful. There's no place where I have an X to a power of an X. But I do have a big mixture of a quotient rule, product rules, chain rules. And so in this case, it's going to be helpful even if I don't have to use it. I could do that quotient rule with all those product rules. Back to C, again, I have some X's down here and I have X's up here. So I have X's to the power of more X's. So again, this one is going to be necessary. And in this third, or in this fourth one, this D, it is neither, it is not helpful because it's all being added together. And we said that when things are being added together, that's the time when we don't want to use it. So then with E, we're back to having X's to the power of X's. So we're back to this being necessary. And then with F, it's neither again. Because the first thing I have a number to X's, then I have a plus. So that plus is like, well, that's not going to be useful. I can't even use the ln. And then I have X's with a number up there. So both of these are the rules that we already know. So again, are there any questions about how we picked these things? Most of you were getting there, but for those of you that had struggled with one or two of them, are there any questions as to why they are the things they are?
Yeah, you mind just re-explaining why B is helpful?
So B is helpful because there's no place where I have an X to a power of an X, first of all. So if we look at the first X, it's X to the power of 5. 5 is a number. The second X, it's E to the power of X. Well, E is a number. So then we have ln X. We never have X's to the power of X's. So in that case, it's definitely not necessary, which leaves either helpful or neither. So far so good in terms of that?
Yeah.
Okay, so it's either helpful or neither, but there are no plus signs. This is all being separated just entirely by multiplication and division. If I were to change this to have like 7x to the 5th plus e to the x plus ln x, then suddenly wouldn't be helpful anymore. But because there are no pluses and minuses combining these things, it's all multiplication and division, that's the time when it's going to be the most helpful.
Okay.
Does that make
Perfect.
sense?
Thank you. Yeah.
Okay, all right. So what we're gonna do now is these problems. We have about 20-ish minutes left of class. Let's do the problems. So we will start with A. So y was equal to, I believe it was this one. Yeah. So I start by doing ln of both sides. say do their derivatives. Do I have the same problem in this one as I did in the last question, where I'm going to have to separate that 8 away before I can bring the power down? Or do I need to bring the power down first? Yeah, good job, guys. We're going to bring the power down first. The reason being that that 8 is inside the parentheses to the power of ln x. So we bring the power down first. It is different, and I'm just going to go up for a second for us to look at it. It is different than what we had right here, where that 2 was not in parentheses to the power. So we had to separate the 2 in order to bring the power down, whereas here I can't separate until I bring the power down. So I'm going to have y prime over y, not y prime over y. We're simplifying here. What am I doing? So I'm going to have ln y is equal to ln x times ln of all of this stuff. Okay, is there any simplification left that I can do? So here I did my third rule. Let's write 3. Are there any rules left that I can use to simplify this more? What can I use to simplify this more? I can use 1 now because I have a product. How many things do I have in my product? I have a product of how many things? You got it, 3, because remember we count the constant. So I have a product of 3 things there. So ln y is equal to, we're using our first rule, ln x times ln 8 plus ln of x squared plus 5 to the 4th plus ln of 2x minus 6 to the 5th. Is there any more simplification I can still do? I can use 3 again. I couldn't have started off with that 3, but now I have it, so I can use the 3 again to bring these new powers down because I've separated them from each other. So we're using 3 again. And I'm going to have ln x. Now notice this ln x is being multiplied by everything. It's like I have these big parentheses here, and these parentheses that I have are super necessary. So I have ln 8 plus 4 ln of x squared plus 5 plus 5 ln of 2 to the x minus 6. Now, are there any more rules that I can use? Anything left I can do? Got it? Nope, we're done. Right, Nick? Now we do the product rule. And our product is ln x times this giant thing. So that's my product rule that we knew we were going to have. So if it hadn't shown up, we would have a problem. We knew that this was going to be a product rule. We found our product rule. Now we will do our product rule. So I'm going to get y prime over y is equal to the derivative of the first times the second plus the first times the derivative of the second. So the derivative of ln 8 is 0 plus 4 times 2x over x squared plus 5 plus 5. What goes on the top of that? What's the derivative of 2 to the x minus 6? What should I put on the top there? You got it, Nick. Good job. 2 to the x ln 2. And then in our final step, we multiply the y over. And this is another place where you need to be careful about your parentheses. So my y here, my y here, when I multiply it over, I had a product rule over there. So y prime is equal to the original function Now I'm going to open some parentheses. I'm going to do these as brackety parentheses. It doesn't matter. They can just be big round parentheses times this. And that's my final answer. Are there any questions about this problem? And notice how even though we were doing logarithmic differentiation because it was necessary, we still used the log rules to simplify the thing as much as possible. And we avoided a product rule that had like 2 chain rules in it, and by using those log rules to simplify. And notice that that product rule would have been inside a chain rule that was inside another product rule. We avoided that by using our log simplification rules. Okay, so we have about 10 minutes left. So I'm going to say we probably have time to get through 1 or 2 more problems. So I want you guys to look A to F. We just did A. Pick one. Which do you guys want to do? Mikhail says F. Well, we can do F really quickly. So why don't we just do F, because that's going to be super fast. So F we said was neither. It was y is equal to 7 to the x squared plus 2 plus x squared plus 2 to the 7. While we're doing this, be thinking about the other ones you want to do, or the other one you want to do. So This is just the rules that we reminded ourselves of in the beginning. We said that the derivative of a to the g, so a to a function, is a to the g times ln a times g prime. And we said that g to a power is n times g to the n minus 1 times g prime. And in this case, I can just use those two rules because I don't have x to the x. I have a plus in between them, so I can't even use a log to separate them. So I just apply my rules directly. So y prime is 7 to the x squared plus 2 times ln 7 times the derivative of x squared plus 2. And then this is 7 times x squared plus 2 to the 6th, I subtract 1, times the derivative of x squared plus 2. So then y prime is 7 to the x squared plus 2 times ln 7 times 2x plus 7 times x squared plus 2 to the 6th times 2x. And that's my final answer here. So this one was pretty straightforward because we just had to apply rules that we already knew. All right, one more, guys. We'll come back down if you haven't finished writing. Mikhail says D. I'd rather do one that has logarithmic differentiation. So we're going to say your choices are B, C, and E. So I've got a lot of private answers. Z is not a... Sorry, Marina, there is no Z. Okay, so it seems like there's a lot of like, everyone's voting for different things, but if we go by the majority, unfortunately for those of you that did not vote C, we're going with C, because that's what the majority went with. So we're gonna do C. And then I don't think we will have time because I'm sure this is gonna take us 5 minutes. But C was this one, right? It was this one, right? Yeah, okay. So C is y is equal to 8 times x sine squared 2x, all to the 4x cubed minus 2x plus 1. And we said it's necessary here because I have x's in my base and x's in the power. So I'm taking ln of both sides. Ln y is equal to ln of this stuff. And remember that we said that when you have a trig function, it's a smart plan to take that power and move it to the end immediately. So I'm moving it to the end immediately. Good. Now, what's my first rule? Am I bringing the power down or am I separating the 8 away? I'm separating the 8. That 8 is not to the power. So we're starting with rule 1. And this is going to be ln 8 plus ln of x sine of 2x squared all to the 4x squared cubed, my bad, 4x cubed minus 2x plus 1. Now what? What's my next rule? You got it. I'm going to bring that power down. So now I'm going to do 3. So now I'm doing 3. And I'll have ln 8 plus 4x cubed minus 2x plus 1 times ln of x times sine of 2x squared. And I'm just going to go through this so I don't keep you guys too late. Also, I'm in a little bit of a hurry after class. So I have these two things multiplied together now, which means I can go back and use 1 again. So this is equal to ln 8 plus 4x cubed minus 2x plus 1 ln x plus ln of sine of 2x squared. Is there any rule left that I can use? Which one? What rule can I still use? I can bring the 2 down, exactly. I still have this power of 2, so now I'm back to being able to use 3 again. Which gives me ln 8 plus 4x cubed minus 2x plus 1 times ln x plus 2 ln of sine of 2x. So I actually used both rules, 1 and 3, 2 times. Are there any questions about that simplification? Okay, I am going to do this somewhat fast just because I am in a little bit of a hurry after class. If you want to talk about it at the beginning of next class, we can. Now I'm taking the derivative. Y prime over y is equal to 0 plus my product rule, the derivative of the first times the second plus the first times the derivative of the second. Which has a little chain rule in it because when I'm doing the derivative of sine, I get cosine, but I need to multiply by 2. And then for step 4, I bring my y over and I get that y prime is equal to the original function times my product rule. And that is my final answer. And we are officially done today, which means we're also officially done with logarithmic differentiation. Next class, we're moving on into a new topic. That means we're also officially done with differentiation techniques. So our new topics are going to largely be based on what we can do with differentiation. We're going to learn how to curve sketch and we're going to learn some economics applications.